All right. Still in Unit 1, Chapter 5, spiraling back now to box plots again. And again, box plots are also called the box and whisker plots. You're used to a nice visual representation of dispersions that shows the smallest value, the largest values, right, of each. Like those are your end points of your whiskers. Your box, Q1 and Q3. For quartiles, Q2 is also the middle, which is also the median, right? The interquartile range is the length of the box, but it's not the actual box itself. The interquartile range is just the length of the box, but it's not the box. The median is in the box, right? That median is in the box, but it's between quartile 1 and 2. So for example, from an AP statistics teacher, and they hear that every one of her 27 students received a 3 or higher on the AP exam. So she treats them to a game of bowling, right? If that's what she hears. So the individual student scores are this. Again, pause the video. Write them down because we can do all this on the calculator, all right? So those are all the scores, all right, on that bowling. Their students note that the greatest score is 215, the smallest score is 70, the middle is around 140, all right, the middle of the top half, or that quartile 3 is 160, and the middle of the bottom half, quartile 1 is around 100. Excuse me. So, show a box and whisker plot of the data. Well, you could use your calculator, all right, this is already given to us, so I have my low, my high, my quartile 1, quartile 3, and the middle, okay? It's the middle of the data. The display consists of 2 boxes and whiskers on the outsides. The box shows the spread of the 2 middle quartiles. The whiskers show the spread of the 2 outlier quartiles, basically. So let's try to plug this data on the calculator and make it ourselves. So we'll go to Stat and Edit, right? And we have our list 1, clear it out, highlight it, press clear. All right, not delete, press clear, and then plug in all of our bowling scores. Excuse me. Then press Stat, and we arrow over to highlight Calc. We're doing 1 variable stats. We press Enter, and I find my median. I find my mean, right? And if we scroll down, I can find basically everything I need for my box and whisker plot right there. My total number, my low, my high, quartile 1, quartile 2, quartile 3, all right there. But now to create our box and whisker plot, right? You press second and Y. We gotta make sure that our plots are on, right? So once I make sure my plot is on, we have our box and whisker plot here. The data is in L1. I have to make sure I have that stuff all there set up. So highlight the box and whisker plot, right? Make sure it's in L1. So I highlighted it L1. Press second in mode so I can quit out. And now I'm going to zoom stat, right? There's zoom stat. That's what it looks like. And there is your box and whisker plot. And again, you can highlight each of those specific spots. If you press trace again, it will highlight, hey, there's your median, there's your quartile 1, quartile 3, your high, your low. So by pressing that arrow key over again, we can find each of those values. When a distribution is strongly skewed, or when it has pronounced outliers, drawing a box plot with its 5-number summary gives a more useful description. All right, that's calculating a mean and a standard deviation. We can get a rough gist of what the graph will look like. Remember, values more than 1.5 times that quartile range, interquartile range, outside the 2 boxes are plotted separately as outliers, all right, or dots. So for example, inputting the lengths of words in a selection of Shakespeare's plays result in a calculator output of, right? So all that I'm saying is I'm giving this to you. I'm doing this work for you. It says inputting the lengths of words in a selection. So all the words, inputting the lengths, all right, I now have the low, the highest one, the quartile range of them, quartile 1, quartile 3, the median, right? So we have that. Outliers consisting of any word lengths less than, I find that quartile range. Well, the quartile range is basically 2. 2 times that is 3. So basically, if I take what quartile 1 is and I subtract that, I get 0. What that basically means is, so 0 is the low. Anything outside of 0, well, you're not going to have negative length words. So whatever. Don't worry about it that way. But the other end of the spectrum, 1.5 times the interquartile range, well, the third quartile is 5. All right, I take that and add it to it. So basically, when I do, that's 8. So anything that is out there above 8. Well, that max, right, we're taking a look at this. So it's 5 plus 3 is 8. So you're looking at the range saying, okay, so anything above 8? Yeah, I definitely know of one thing at least that's above 8. So that is definitely an outlier. So a box and whisker plot for this, so you can see, this is just a histogram showing you what's happening, but these are all anything above 8. Well, there's a 9, there's a 10, there's an 11, there's a 12, so those are outliers for it. So when you're seeing or drawing a box and whisker plot, you need to remember that the dots, they represent those spots, those points as outliers when you're looking at it. Okay? Also note, it should be noted that 2 sets can have the same 5-number summary and thus have the same box plots but have dramatically different distributions. So take a look at this example. Set A. As I'm looking at all of my data, you want to pause the video and write this down so you can write these data sets down. Set B, here's the data set for that. They both have the same low, notice, and they both have the same high, so that'll be the same in both. Simple inspection indicates that they are obviously different distributions. However, the TI-84 gives identical box plots. The min 0, right? Max 100, and if you were to plug this data in, this is what I would get for my quartile 1, 2, and 3. And even if I plug this in, I would get this for quartile 1, 2, and 3. I get identical. If we use a calculator to plug in A, if you don't believe me, clear that out, plug in all your data, press the arrow key over, right? Scroll down, and there they are, right? We can physically look at our data set and see those. So we just need to find 25, 50, and 75, right? Calculate set B. So I erase that all out, clear, press clear, type in my new set of data. I press enter. I scroll down with my one variable stats, and look, I get the same exact thing. So whether you believe me or not, all right, you can plug it into calculators to verify that they are basically going to be the same 5-number summary, same box plots. So comparing distributions, the numbers of wins, for example, for 30 NBA teams at the end of the 2014-2015 season is shown in the following back-to-back stem plots, right? So here's the Eastern Conference, what they won. All right, this team won 18 and 17, 25, 32, 33, right? Over here, 45, 45, 50, 51, so you can see how it works, okay? It's just a combo on each side. When comparing the shape, the center, and the spread, right, this one looks reasonably uniformed, right? Eastern Conference seems kind of bell-shaped. This one seems a little bit more skewed, a little bit, right? That way. The shape, the distribution of wins in the Eastern Conference, again, was roughly bell-shaped. The distribution of wins in the Western Conference is roughly skewed towards the lower end a little bit, right? Didn't have many in that lower end. Center, right? Counting values to find the middle gives the median of the Eastern Conference to be around 38, right? And the median of the Western Conference to be 45. So let's see, looking back at it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So around 7.5. So 1, 2, 3, 4, 5, 6, 7. So yeah, right around 32, 33. Somewhere in there would be the middle. And over here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the same deal. 1, 2, 3, 4, 5, 6, 7. So around 45. So we said around 32-ish and 45-ish. Well, there's the 45. So it said theirs would be between, Eastern Conference would be, the middle would be around 38. Let me see that again. Did I go backwards maybe? Around 38. 1, 2, 3, 4, 5, 6, 7. Yeah, around 38. So I was looking at it the wrong way around. So around 38 is what it would be, and 45. So yep, the Western Conference distribution of wins has a greater center, right? The spread, right, is the range of the Eastern Conference. There's your range. The range of the Western Conference of wins, right, 51. Thus, the Western Conference of distributions of wins, their distribution of wins has a greater spread, okay, of the Western Conference. And again, when asked for a comparison, don't forget to address your shape, your socks, right? Your shape, your outliers, your center, and your spread, all right, which is basically our socks. You must use comparative words. That is, you must state which center and which spread is larger. All right, if you're comparing them, which spread is larger, all right, which center is larger. They are also saying, or if they are approximately the same, you want to say that. Simply making two separate lists is not enough, and you will be penalized on the AP exam. Although both sets in this example are of the same size, it generally you don't have the same number of data points on each side when you're doing stuff like this. Take a look at another example. The following are parallel box plots showing the daily price fluctuations of a certain common stock over the course of 5 years. What trends do the box plots show? So, you have your box plots, right? 2013, 14, 15, and 16. So here are your trends. As I'm looking at this, it looks like the median, that middle, is at 58-ish maybe, and then it's higher, up to 62-ish, 65-ish, 72-ish. So the median keeps going up. All right, the range, or your interquartile range, is roughly the same. It looks like from here to here. It shrinks up a little bit, but roughly the same. Right? Everything seems to kind of keep trending up, is what it appears to be looking like. If you look, it says tip. Don't forget to label and provide a scale for all the graphs that you do, so we know what you're looking at. Like, I know this direction now and that direction. The parallel box plots shows that from year to year, the median daily stock price has steadily risen, right? Median, it kind of keeps rising up from the roughly 58 to now it's the whole way up to 78. The third quartile value has been roughly stable, though. There's a third quartile, and it's pretty much the same. That's never changed, that third quartile. It's pretty steady around in there. The yearly low has never decreased, right? The yearly low has never decreased. It stayed the same, and then that low has also went up. The interquartile has never increased from one year to the next. The interquartile range has never increased, right? It looks like about the same, and then it looks like about the same, but they're decreasing from this grouping to this grouping, so it's never went up. In the next example, the graph below compares cumulative frequencies, and I think we'll stop there and come back, and hopefully we can try to wrap up.